Hello, my name's Brianna Coffer, and today I'm going to be talking to you about an interdisciplinary science and ELA sample lesson that I put together to encourage students to build upon their critical literacy skills by utilizing empirical data that they collect in the science classroom. So the proposed collaboration actually covers a lot of different standards, not just Common Core state standards for ELA, but also NGSS standards in science. Both sets of standards place a very heavy emphasis on argumentation and also being able to interpret informational texts. Some of the activities that you'll see in this lesson can be done independently, either in the science classroom or in the ELA classroom, like by themselves. But collaboration really is a large component of what creates authenticity. So I encourage this work to be done together. So first I'll go through kind of what goes on in the ELA class in this proposed collaboration, and then I'll talk a little bit about what goes on in the science classroom. So inside the ELA class, they cover this specific standard that you will see up at the top of your screen. And this standard wants students to be able to cite specific textual evidence to support analysis of science and technical texts, attending to important distinctions the author makes and to any gaps or inconsistencies in the account. In order to satisfy this standard, an English teacher might pose the question, what is climate change and how do we know what we know about climate change? If students were to Google something like, what is climate change? Or are there panels on climate change? They might come up with these two documents that you'll see on the right, the IPCC and the NIPCC. At first glance, these documents might look really similar to each other. And as we know, when you Google things, there is an algorithm that takes the history of your searches, the location, information pulled from your stored accounts, and it influences really what you see. So for some people, you might see the IPCC document first, and for others, you might see the NIPCC document. And in the ELA class, they will look at both of these documents and assess them for similarities and differences. And they'll also use a critical lens to view the materials within them. This is just the beginning of students using their critical literacy skills to decipher between what is empirically backed research and what might be influenced by other sources besides empirical data. So in the ELA classroom, students might analyze graphics from the NIPCC document and the IPCC document and look for similarities and differences. They might also look at graphs from these documents and see how they compare. And ultimately, what we want them to look at is that even though these two documents display graphics and graphs that might look similar to one another, they have very conflicting views. And so, how do we really decide what is truth or what is not truth? And how do students interpret that? And so, English teachers will take them through the idea of looking at something through a critical lens. They'll also talk about source credibility. How do we know what we know? How do we select certain sources of information? How might we tell the difference between something that's empirically supported and what might be pseudoscience? Another document that they might look at in the ELA classroom is this NIPCC versus IPCC document. At first glance, it might seem like, oh, there really are two sides to this argument. And here is a way that I can tell the difference between these two documents outright. But they will later learn that Fred Singer, the author of this document, is one of the leaders of the NIPCC. So it's not something that's credible because it's entirely biased. Students will also explore the created illusion of both sidesism. And after creating and collecting a toolkit of sorts, they'll go back through and analyze the NIPCC and IPCC documents again. But even with that new lens or that new framework to look at these documents with, it's really hard to just analyze text and to be able to say, well, this is true or this is not true based upon what I know about authors. Even when you look at all of the different supports, the tenets of critical literacy are really being co opted at the moment. Even with the NIPCC document, they use a lot of mirroring in order to make it look like the IPCC document. So it's trying to mask as empirical data. And so, even with all of those critical literacy skills and that toolkit that the students are building, um, it's really helpful for them to ground those skills in being able to see the actual empirical data. As scientists, we navigate conflicting information by analyzing empirical data. And so it's important that we allow our students opportunities to do the same. This not only empowers them to create and justify arguments that they make, but it takes the literacy toolkit that they're collecting in English and makes it even more actionable and authentic. So while they're doing that concurrently in the English classroom, inside the science classroom, they'll be taking a lot of those concepts and looking at empirical data that backs them. This really allows students to do what Freire referred to as reading the word and the world. Science can go beyond the text in a way that ELA sometimes can't. We also know that scientific knowledge is public and vetted and built by consensus. It often takes time to be adopted and embraced. And so, by showing our students this empirical data that really acts as a pillar within argumentation, we provide them with the evidence that they need to use their critical literacy toolkit in an actionable way. So, the science lesson that the students will be doing during this time has to do with climate change. It revolves around how ocean acidification, due to climate change, impacts different organisms, particularly our calcifiers. And so, they'll go through a 5E lesson, meaning that they'll go through an engage, explore, explain, elaborate, and evaluate step. And so, in the engage step, they witness an ocean acidification demo which involves acetic acid and sodium bicarbonate. And so when you combine sodium bicarbonate and acetic acid together, it creates a carbon dioxide gas. And so in this small cup, inside of a larger cup, that chemical reaction is going on and producing carbon dioxide, which is then seeping into the water below inside of this cup, causing it to turn yellow. So even without contact from this chemical reaction, just the byproduct that sort of mirrors our excess carbon dioxide in our atmosphere and other likewise greenhouse gases, and shows them how those excess gases impact our oceans. Then they'll go through an explore explain step in something called the Virtual Urchin Laboratory from the University of Washington. They'll go through a range of different simulations that provide really heavy scaffolding for a range of different students. They'll practice reading graphs, they'll practice looking at a pH scale, practice logarithms, they'll identify between calcifiers and non calcifiers, and then they'll also gather some information about the sea urchin life cycle. So then they'll go through their Explore Explain step, which is the first portion of the virtual urchin lab. So what the students will do is they will virtually culture sea urchin larvae over 5 days. It's sped up in the simulation. And they'll culture the larva at a pH of 7.7 and also at an 8.1. And then they will measure the larva from both types of samples to see how the pH has impacted their development over time. After they've gone through and collected that empirical data and done a lot of background research, they'll also practice doing some scientific reading in this elaborate step. They'll read a paper called Projecting Coral Reef Futures Under Global Warming and Ocean Acidification. This is a paper that's specifically referenced by the NIPCC, which uses it to claim that the organisms within our ecosystems, particularly our marine ecosystems, are super resilient to climate change and that they can bounce back and it's basically good for them, which we know is not true. And this is where the two interdisciplinary lessons begin to combine because not only are they reading in this empirical study that increase in pH is not good for calcifying organisms. They've done in the past couple of steps of this 5E lesson, they've cultured these larvae themselves and they've seen that an increase in acidity severely impacts and stunts their growth. They continue to build their literacy skills and also to reground them with this empirical data that they've collected in what's called a spawn activity. A spawn activity is a writing task that's an acronym. It stands for Special Powers, Problem Solving, Alternative Viewpoints, What If, and Next. And so students get to go through different prompts and choose which one they would like to answer, but all of them allows them to use their literacy skills and the empirical data that they've collected in order to write about some sort of scenario. I'll go ahead and open up our prompts here. So these were some of the prompts that the students are given. And so they would pick one of these, and a lot of these are either very relevant and authentic to their life, or they allow them to write as a scientist, which I believe is really important to this whole collaboration. This really serves to act as the evaluative piece or the assessment portion of this lesson. I also believe that this lesson can be followed up by Socratic seminars or other constructive argumentation that allows them to use the data that they've collected and also the critical literacy toolkit that they've been building in order to further analyze true climate science data and pseudoscience. Hopefully that was helpful. Thank you so much for coming to the Critical Literacy Conference of the Americas. We're so excited to have you here. Thank you for investing in your students and your teachers and your teacher educators.